Good morning, grade 10. Today we're going to look at the graphs of exponential and logarithmic functions. It is also important that you know how to graph these functions as well as use your calculator to find the graph or how to make a graph. Okay, so we will also discuss the differences of an exponential graph and a logarithmic graph. Okay, so let's go over and review your logarithms. Okay, given y is equal to b raised to x, if you're going to rewrite it using logarithm, you may rewrite it as logarithm of base b of y is equal to x. Remember, I told you that you can change this depending on how you think you will remember this. So, in this case, this b can easily remind you of base and x being exponent or index. Okay, there are many examples that you can, or many problems that you can solve using logarithm. And normally in math, you will use, especially if you go to math studies, you use logarithm to solve the time of your compound interest. So you use logarithm to find when the exponent is the missing value. Okay, so to continue, let's go over some few properties of logarithms, like shortcuts that you should be able to think right away what will be the answer. Okay. First one is when you see logarithm of base b of 1, you should know that it's equal to 0 because any number raised to 0 is equal to 1. So you should be quick at this. The second one that you should know is the logarithm of base b of b is equal to 1 because any base or any number raised to the first power or raised to 1 is equal to b. Okay. And the last one is the logarithm of base b of b raised to the r, and you will see an example of this when you go and study the other laws of logarithm. So the logarithm of base b of b raised to the r is r simply because b raised to the r is the same or equal to base raised to the r. Okay. Now, let's move on to our topic. Okay. Let's talk about the general form of exponential function, or let's look at the graph of a general form of exponential function. So this is the general form of exponential function graph, wherein for exponential function, it's y is equal to b raised to the x. So this is your general form for exponential function. And your base should always be greater than 1. Okay, so your b cannot be 0. Okay, so 1 or bigger than 1. No, it should be bigger than 1, sorry. Okay, one of the properties or characteristics of exponential function is that the domain are all real numbers. Okay, so that will include negative and positive values. When we say domain, I hope you still remember that these are your x values, what you can use for your x coordinates when you are graphing. Okay. Second property or second characteristics of exponential function, the range or the y values of your y coordinates will always be greater than 0. Okay, so it will never be equal to 0, so should be greater than 0. Okay, there will be no x-intercept. It will never touch the horizontal line or the x-axis. So if you take a look at this red curve here, okay, this red actually will never touch the x-axis. Although in here it seems like if you extend the red, it seems like it's along the x-axis, but it's not. It's just threading along the x-axis but not touching it. Okay, so there's no x-intercept. And for exponential function, it will touch along y-axis only at 0.01. When your x is 0, your y is 1. Okay, now in this column, I've written all the properties or characteristics of exponential function. So on this side, I'm going to start to write down all the properties or characteristics of logarithmic functions. So you'll see the differences between the two. Okay, first, your y equal to b raised to the x in logarithmic function will be written as y is equal to the logarithm of base b of x. Okay, this is the inverse of y is equal to b raised to the x. I've mentioned this already in our first lesson about logarithm. Okay, the second difference here is that the domain in here, your x is greater than 0, wherein here, this one is the opposite of this. Okay, so guess what is the third difference? Okay, your range now is going to be all real numbers. Okay, so your range, your x value, your values now will be from negative, you'll have negative values and you will have positive values. Okay, if in exponential you don't have an x-intercept, for logarithmic function you will have an x-intercept, but it's going to be 1 is equal to 1 and 0. So your x coordinate is 1 and your y coordinate is 0. So I know now that you will know what will be the last one. So y-intercept in logarithmic function is non-existent. It will never touch the y-intercept. Okay, so let's take a look at one example. Your exponential function y is equal to 3 raised to the x. If you rewrite this, if you write this in logarithmic form, okay, this will be written as the logarithm of base 3 raised to the x. So if we put values in there for your x, okay, this is what it will look like. In your exponential function, okay, it touches the y-axis at 0, 1, whereas in your logarithmic function, it touches the x-axis but not the y-axis at 1, 0. In exponential function, this line is threading along the x-axis, but it will not be touching the x-axis because there's no x-intercept. On the other hand, for logarithmic function, the tail of the curve will be threading along the y-axis but will never touch the y-axis, okay, in here. Okay, so that's the other difference. And then you see like it's just the inverse here. Okay, now let's have an example how to graph it. Now when you're graphing it, you're giving values for the x. Okay, so you are assigning the x, or in the problem you'll be given values of x. But if it just say graph it, then give values, assign values. Okay, so here's a table of values. We're going to graph y is equal to 2 raised to the x. Okay, here's the table. On this column, I assigned -3, -2, -1, 0, 1, 2, 3. These can be any values. It's just that it's better to graph both negative and positive values. Okay, so in here, I use from -3 to 3. Okay. If we substitute -3 to this x, so you will have 2 raised to -3, you will get 0.125 or this is the same as 1 over 2 raised to negative 3. Remember that when you have a negative exponent, it means that you will have a value less than 1. Okay, so you get, if you use your calculator, you're going to have 0.125 or 125 thousandths. Okay, now replace negative 2 to x and you will get the value 0.25, or this means that 1 over 2 raised to the second power, which is 1/4, okay, and then it's equal to 0.25. Now let's go here. Let's replace the exponent by negative 1. So this will become 2 raised to negative 1. And 2 raised to negative 1 is equal to 1/2. Okay, 1/2 is 0.5. There you go. Now, this time we replace x by 0. Any number raised to 0 power is equal to 1. So 2 raised to 0 is 1. There you go, your y value. Then put 1 here in the exponent. 2 raised to the first power is 2. So you have your y value 2. Then we're going to use 2 for x. 2 raised to the second power, or 2 squared, is 4. 2 raised to the third power, or 2 cubed, is 8. So if you graph using these values, you will have this kind of graph. Okay, as you notice, this touches the y-axis at 0, 1. Okay, here you go. It's the characteristic of a exponential function. Okay, so let's write here. What is the domain and range of this function? We already discussed this. Domain are all real numbers, and then range are y is greater than 0. Okay, so you will see here you have real number here on your domain, and then in the y column you never had a 0, but instead all of them are greater than 0. Okay, now let's move on to the logarithmic function. It's going to be the reverse. So you're looking for y is equal to logarithm base 2 of x. Okay, this should be y is equal to logarithm of base 2 of x. Now, we're going to use the value of y in the other slide. I'm going back here. This is what I'm talking about. We're starting from 1.125. If we go now, okay, so 0.125, 0.25, 0.5, 1, 2, 4, 8, you will get the reverse. Okay, so this time you will have the y values. Okay, so if you look at the graph, it will be the opposite, and this is what it would look like in a calculator, or if you graph it manually in your graph paper. Okay, so then your domain and range of this function is going to be the domain are x is greater than 0. You will see here all your x values are greater than 0, and then your range, okay, in your y are all real number with negative values. Okay, so let's check your understanding. Open your textbook and graph or answer numbers 1 and 2, which you will be graphing on page 217, exercise 805. Remember that for the values of x, you will assign it for your exponential graph. You will assign it, you will have your own values. But please use -3, -2, -1, 0, 1, 2, 3. Okay? Unless it's specified in the problem. Okay. Work hard, grade 10. Make sure that you are learning even if I'm not in the classroom. Okay. Bye.